everyone, Steve here, and welcome to this week's episode of
Bang Science!
This week, we'll be sculpting with warm ice, unlocking the secrets of aerodynamics, and as usual, later on, we'll be showing you experiments that you can do in your own home. A reminder of what you'll need is on our website, bangscience.com, and from there, you can even send us a little message during the show. Just remember to ask your parents' permission first. And now, let's go straight to our first experiment of the show.
Welcome to Bang Science!
Here we are in the danger zone, and I'm joined by my good friend, Professor Matt Braden. How are you, Matt?
I'm doing well, thanks.
Good man. Now, today, we're going to show you how to make warm ice. And no, I am not going to fart on an ice cube. This is real science. Today, we're going to be using some sodium acetate, some water, a fridge, any household fridge will do, a dish, and of course, my trusty spoon. So, warm ice. How are we doing this, Prof?
OK, so to start with, we're going to measure out 100 grams of this sodium acetate.
OK.
You want to do that?
100 grams.
And just pour it into the dish here. Perfect.
Is that enough?
Yeah, that's fine. OK, and now we're going to add water to it.
OK.
Just like that. OK, and now what I need you to do is slowly stir it. I'm just going to turn on the heat.
OK.
Yeah.
So what exactly is the science behind this warm ice experiment, Prof?
Well, basically, warm ice is an exothermic reaction, which means it gives off heat when its chemicals react.
OK.
The crystals inside it melt at 56 degrees centigrade, and this dissolves into the water. And then at 100 degrees centigrade, there's more material in the water than the water can handle, and this makes it super saturated. Super
saturated, OK. So where would we use this in everyday life? What would you use it for?
Well, sodium acetate is used in many things. It's used in hand warmers because it gives off heat. It's also used in concrete to prevent water damage. And it's used to help flavour your school dinners.
Flavouring food?
Absolutely.
No way, that's crazy. OK, Prof, well, I think this solution is pretty much dissolved, so what's the next step?
OK, so let's pour it into this glass.
Pour it in, OK. Don't worry, I've got steady hands.
Absolutely, be careful with it.
It is dangerous chemicals, aren't they? So we'll just get it in there nicely.
That's great. OK, so now we're going to pop it in the fridge.
Pop this in the fridge.
Yep.
And luckily, through the magic of TV, we've got one that we prepared a little earlier. So, here we go, sodium acetate.
OK, so now what we're going to do is we're going to try and make an ice sculpture with this. So to start with, I'm just going to pour a little bit in there.
OK, so that's a liquid at the moment.
Yeah, so if you want to poke it.
Poke it?
Yep.
What will that do?
Hopefully, it'll turn solid. You might have to do it a few times.
OK.
Is it going?
It's turning a little bit solid, yes, Prof? There we go, there we go. It's crystallising now. That's amazing.
Perfect. OK, and you can see it slowly spread. And what I'm going to do is I'm going to pour a little bit more on top of it, and hopefully it will pour a little sculpture.
No way, look, look, look. It's building, it's like a little sculpture. That is amazing. There we go, everybody. Warm ice. Awesome. Thanks, Prof. That's really good. I'll make sure I come and see you next winter for a pair of woolly gloves, yeah?
Exactly.
Thank you, Prof. Anyway, now we're going to go straight over to Aileen, who's been visiting a couple of local primary schools. She's flown off to Walton High and Western Academy to tell us all about the aerodynamics of paper aeroplanes. Chocks away, Aileen!
Hello, and we've come out to visit two schools in Stafford today to look into the aerodynamics of paper aeroplanes. Now, let's go see him. Here we've got a plane, and we're going to look at the 4 forces that make a plane aerodynamic. First of all, you have the thrust of you throwing the aeroplane, which pushes it forward. Then you have the drag, which is the wind at the front pushing it back. You then have the weight. The weight is quite important, as if this holds it down so that it will go. Finally, we have the lift. This is when the wind below is a greater pressure than the wind above the wing. The faster the plane moves, the further it will go. What we want you to do is we're going to get you to make your own little aeroplane based upon this. That way we'll then go outside and we'll throw them around and we'll see who gets the furthest, who wins, who's the best, who's the most streamlined. That's it. We've got scissors, glue, materials. Get stuck in. Yeah? Is that your base there?
Yeah, that's our base, and we're going to put cardboard bits on the bottom to make it stronger.
Oh, good. Alright, so you've gone for the aerodynamic approach. How aerodynamic do you think it is?
Very, because we sellotape that one over. We put too much sellotape there, so the wind won't be able to get through. So we're putting that one on the front like that, so it'll
It will almost work like a jet engine, sending the same amount of air at the back, pressurised.
If we put the straws underneath the wings, it would like lift them up.
5, 4, 3, 2, 1. That's it. Time is up, so put on your finishing touches. Because that's it. Well, now that time's up for both teams, stay tuned so we can see how they get on with their testing later.
Thanks, Aileen. Let's hope her experiments don't hit any turbulence for now. But let's move on and take a look at the latest in Science News!
Now for Science News.
Science News. Now, first on the agenda, Harry Potter fans, take note because invisibility cloaks may not be as magical as you'd think. Students at the University of Texas are looking at using carbon nanotubes. These tubes work in a very similar way to mirages in the desert. They're heated using electricity, and then the difference in temperature between the tubes and the water around them bends light away from the tubes. Stay with me on this, Prof, stay with me, making them appear invisible. Now, although at the moment they can only be used underwater and with very small objects, this could soon be a gateway to much, much bigger things. I'm thinking it's a fantastic way to sneak out of detention, if you ask me, Prof.
Disgraceful. Meanwhile, students at the University of Tokyo are looking at the same blue screen technology used by filmmakers to create the effect of invisibility. They do this by filming the background behind a person and then projecting it onto their cloak. Very sophisticated.
Very sophisticated indeed, Prof. Yeah. Now, speaking of all things invisible, 4 new species of chameleon have been discovered in Madagascar. These chameleons are only tens of millimetres in length, making them like just properly tiny.
Yeah, they are normally brown, but when they become stressed, a white stripe appears on their back. Now, some species of chameleons are known for changing their colours to show emotions to other chameleons or even to blend in with their background. But this is the first time we've ever found examples this small.
No, they are tiny. Very cute, but I can't imagine them being very good pets. I think I'd tread on them very quickly. But moving on, it was recently discovered that 56 million years ago, that's like a bit longer than 55 million years ago, one of the first horses,
Sifrippus?
That one, lived on the Earth. Now, Sifrippus was about the size of a small dog, and scientists have recently discovered that it shrank as the planet warmed up.
Yes, during a time called the Paleozone-Eozone thermal maximum, the average temperature raised by 8 degrees over 175,000 years, and the average size of Sifrippus shrank from 5.5 kilograms to just 4 kilograms. Now, scientists have already discovered that animals living in warmer climates are smaller than those living in cold climates. This is called Bergmann's rule. But this is the first evidence that it also happens over a period of time as the planet's temperature gets cooler.
Good. Now, similar to horses, I have found out a fantastic fact about these bad boys. Yep, goats. Now, scientists have discovered that, like humans, I love this fact, Prof, goats can develop accents. Yep, pygmy goats are raised in social groups, and their calls become more similar in these groups as they grow older. This is thought to be so that they can find other goats from their same group more easily. So this means, just like us humans, goats have got accents too. Hey, can you imagine that, Prof? Can you imagine that? A goat with a Scottish accent. Hey, you going to eat that grass down there, mate? Eh? Are you going to eat it? Can I have it? Can I have that bit of dandelion down there?
Not quite, Steve. Not quite.
Okay.
Researchers have found 700 new planets in the Milky Way and think there may be billions more. They think that each star in our galaxy could have planets orbiting it, and some planets may even orbit 2 stars at once. Overall, they think each star hosts an average of 1.6 planets. By using a method called gravitational microlensing, scientists have been able to look at light up to 20,000 light years away, and they've been studying the data for a whole 6 years.
That is huge. And, oh, we've got some breaking news now coming through from the Large Hadron Collider. You know, that's the big machine in Switzerland that's trying to find out what happened at the time of the Big Bang. Well, they've had a breakthrough, and they're just getting ready to power up the machine for the final time. Now, the Large Hadron Collider, for those of you who don't know, I'm sure you do know, Prof, because you're really clever, is a huge machine which uses massive magnets to make particles smash into each other. It's kind of sort of like WWE wrestling, but like much smaller.
And much more exciting, because if they can prove that something called the Higgs boson, also known as the God particle, exists, then we might be able to find out exactly how all the forces in our universe work together, possibly even prove the existence of dark matter, something that scientists think makes up 86% of the known universe.
Wow, fascinating. So, that's it for Science News! Sorry about that. You can find all these stories on our website, along with loads more. But now, let's go back to Aileen at Launch Control, Walton High and Western Academy to see if her ideas have floated. See what I did there? Because it's...
Okay, so in a minute I'm going to get you to all line up and then throw your planes in all in the same direction, and then and then I'll go along to the ones furthest away, and using this meter circle, I will go around and measure, because that is exactly a meter, so I'll walk down and measure whose is the furthest. Now that we've been to both schools in Staffordshire and they've both made their favourite aeroplanes and we went outside and tested them, we're going to go back to the studio and see how well it does in the wind tunnel. Now we're going to go check how well they do in the wind chamber as we look at the aerodynamics of how the wind passes over the plane. Here is our wind tunnel. We have the wind chamber and the funnels. We will be using a fan to pass through the wind through into these straws so that it will be more horizontal around the aeroplane. We're using icing sugar, you'll be able to see the wind, and it will pass round showing its streamlined structure, and this will prove how aerodynamic it is as it demonstrates how the wind passes round it when in flight. So we grab our airplane and pop it inside. This is a homemade wind chamber. Details on how to make one yourself can be found on our website at www.bangscience.com. Wind tunnels are used in the real world by many scientists on actual airplanes to see how streamlined they are. Here's a clip of some that have been used. Well, we had a lot of fun today learning about the aerodynamics, so thanks to Western Road Academy and Walton High. Now back to you in the studio, Steve.
Thanks, Aileen. And congratulations to Gary from Walton High for getting the best aeroplane. A Bang Science goodie bag is on its way to you right now. Now, though, we're going to move on and show you some experiments that you can do in your own home. I do hope you've got your stuff ready.
You're watching Bang Science.
Remember, each week we give out a list of items that you'll need for the following week so that you can join in from home. Now, don't worry if you haven't got the items for this week's Science at Home, because we'll have them all on our website, along with how to conduct the experiments at www.bangscience.com. But for everybody else ready and waiting to conduct their experiments with us live, be sure to keep us updated and let us know how your experiment's going. You can get us on Twitter at #BangScience, and you never know, we could be reading out some of your messages online. So, our first experiment is a homemade lava lamp. Now, these things are great, aren't they, Prof?
Absolutely.
They're really good. They can add a bit of mood lighting really easily. So, if you fancy making one of these, all you need is a bottle, some vegetable oil, some water, some food colouring, and an Alka-Seltzer, a fizzy tablet. So, what do we do, Prof?
Okay, so to start with, you want to pour the water into the bottle. We've already done that here.
Done that.
And then we're going to add the vegetable to the bottle.
Okay.
And wait for it to settle. It does take a while, so we've already done one.
Yep. Get that out of the way.
So here we go. And you can see here that the water and the oil are nicely separated.
Yep.
We'll explain why in just a minute.
Okay.
But the next thing you need to do is add the food colouring in. Be careful at this stage not to spill it everywhere because it does stain.
Okay. How much are we going for?
Just until it's nice and red.
Like that?
Yeah, that'll do.
Yeah.
Okay. You can already see it's starting to look like a lava lamp,
Yeah,
but
it
not
looks
quite.
cool.
So what we're going to do is add this Alka-Seltzer. We're going to break it up first of all to make it easier. You want to put it in?
Good idea, Prof, breaking it up.
See
Okay.
what
Oh,
happens.
wow. Wow, look at that. Straight away, it's gone all splurgy, Prof. What's going on?
Yeah, well, basically what's happening is the oil stays above the water because
Okay.
oil is lighter than water, or
Yeah.
actually it's less dense than water. And the two layers stay separated because of something called intermolecular polarity.
Intermolecular polarity.
That's right.
You must go down a storm with the ladies at dinner parties there, Prof.
I really do. Basically, intermolecular polarity means all the water molecules are attracted to each other and they stick together and loosely bond, a bit like magnets.
Oh, I see. Yeah.
But they repel the oil layer, so the two layers stay separate. And when you add the Alka-Seltzer, the water bubbles up through the oil and creates the water lamp effect.
That is amazing.
And if you want to improve it, add a torch to the bottom, it'll look like a proper lava lamp.
That is fantastic. So there we have it, your very homemade lava lamp. Done. Right, experiment, tick, out of the way. Our next experiment, soap paintings. So, to make a piece of unique modern art, you will need a flat tray, like a sort of cookie baking tray, some food colouring, at least 3 different colours to make the best possible picture, some milk. Now, remember, the milk has got to be full fat milk. Low fat milk will not work in this experiment. And finally, you'll need some washing up liquid. So, Prof, what are we doing?
OK, so to start with, we want to pour a thin layer of milk onto the bottom of the tray, so if you
Okay.
want to do that. Be careful not to spill the milk everywhere. That's good.
There we go.
Keep pouring it, keep pouring it. There we go, perfect.
Is that all right?
That's great. And now you want to add a few drops of the food colouring around the place. If you want to grab those 2 colours,
Okay.
I'll grab the red
see.
here, because red's my favourite colour.
Bit of green,
There we
bit
are.
of blue. Oh,
Right
that's
on.
nice. That's looking
Okay.
nice.
So at this point, the colours are going to start mix a bit, but I think we need a bit more in there.
Okay.
So if you want to add the soap,
Yeah.
you just put a few drops
Just
on.
a few drops,
Just
not
a
too
few
much.
drops, not too much
Okay.
at all.
Let's open it.
Always a good start.
Yep. There we
Okay.
go. Oh, wow.
Yeah,
That's
so you
cool.
see the colours are starting to spread out now.
Yeah, so I understand because the food colouring, it's sort of made it all colourful, but why is it sort of doing this sort of crazy oil spill pattern? What's that all about?
Well, basically, the liquid soap is designed to eat fats because that's what's left on your plate after you've eaten your food.
Yeah.
And the whole milk contains fat. That's why we had to use whole milk and not light milk.
Oh, of course, yeah.
So when you add the soap to the milk, it breaks up the fats and it spreads all the liquid around, which creates this beautiful effect.
That is really lovely. Well, Prof, I'm a little bit thirsty, so I'm just going to take this down.
Wouldn't drink that if I was you.
Why not?
Unless you want to be burping bubbles all day, pour that down the sink, get rid of it, have a glass of water.
It looks like a milkshake.
I know, but really, don't drink it.
Okay, safety first, I suppose. Wise words from the Prof. So, there we go. Thanks, Prof. 2 great experiments. I hope you guys at home have been as successful with yours as we have with ours in the studio. But now, it's time to move on because of the milk.
No.
Oh, OK, Saved by the Bell. That's the nuclear klaxon there, which means, sadly, we're running out of time. Next show, we're going to be making a Coke volcano. So you'll need a packet of Mentos sweets, a bottle of cola, some card, some paint, and, of course, some sticky back plastic. You can find out where to get all of these things by checking our website, www.bangscience.com, along with details of all of the experiments that you've seen today. So, that's it for this week's show. We'll see you next week on Bang Science, where we'll be unlocking more of the mysteries of the universe. Until then, though, it's goodbye from me, it's goodbye from the Prof.
Goodbye.
It's goodbye from Aileen. Thanks for watching. And as physicist and astronomer Carl Sagan once said, if you want to make an apple pie from scratch, you must first create the universe. Or you could just go to Tesco. See you next week, everybody.